The next issue we come to is recompilation. And here's the issue that you run into. The first time you run a stored procedure, that stored procedure gets brought into cache. We pass in the parameters, we optimize the stored procedure, and we store the query plan for the optimized stored procedure. So far, so good. The next time somebody wants to run the stored procedure, they locate the proc, they find that proc in cache. Once they find that proc in cache, they go out to, they plug in the parameters, they take the query plan that's in cache, and they try to run with it. What's the downside there? Well, the downside is we've used the plan that's already in cache. For maybe 98 or 99% of what we're trying to do, that works out great. Bring me all the information for this customer ID. Look up the address for this address ID. Bring me back the sales by month for this salesman. Most of these things take quantities of data which are going to be bringing back relatively similar result sets and bring them back throughout the results of the proc. But how about something like that? Create a proc specifying a range of values, low and high. Now what I want to do is select the sum of the total sales from the titles table where the price is between low and high. Now, if you saw my indexing presentation, one of the things that we spelled out is that these ranges of values can bite you because what ends up happening is the range of values does not necessarily correspond with the volume of data. For example, if I give a range of values between $5 and $20, I'm going to get most of the books at a Barnes & Noble. If I specify the books between $600 and $6,000, I might not get any of the books at Barnes & Noble. So even though I had a $15 range the first time and a $5,400 range the second time, I'm going to get more books back with the smaller range. Now, why does that matter to me? The first reason that matters to me is that based on the number of rows I'm getting back, I may want to use a different search plan, a different different optimization plan. So with a wide range of values, I might want a table scan. With a narrow range of values, I might want to use that non-clustered index. Sometimes we get into a situation where we have an extremely wrong plan up in cache. And that happens with stored procedures on a relatively frequent basis. What do we do about it? The thing that we can do about it is to create the proc with recompile. When I create the proc with recompile, I'm instructing the server to re-optimize the stored procedure every time it's run. Now, I have seen people write things on the internet which have been less than correct, less than intelligent, and less than thought out. Specifically, I've seen people who are otherwise relatively intelligent write things like, it's not worth it to create stored procedures anymore because SQL Server has a plan cache and it's just as fast. That all by itself is kind of silly. The plan cache can have similar types of problems, but here's the thing. If you've got 2,500 lines of code and you're passing that 2,500 lines of code across the network, you have some finite measurable amount of time to get that code across the network. Once it's gone across the network, you have some finite measurable amount of time required to parse the code. Stored procedures are already sitting there, they're pre-parsed, and on a good day, they'll already be up in cache when you want to execute or recompile them. So whether you want to recreate it with recompile, whether you want to avoid the cache plans, whether you want to force a recompile, stored procedures are still a really good way to go. Creating this proc with recompile guarantees that whether I'm going for a range of 1 to 20 or a range of 5,000 to 6,000, I'm going to get a different query plan, and as long as my stats are up to date, that query plan is likely to be the correct one. Now, Sometimes you do not have the control to make a change directly to your production environment. What you want to do is test the theory that your proc isn't running correctly. What you can do then is to execute the proc with recompile. In this example, we're executing range value 10, 20 with recompile. This gets us a new compilation plan for this specific execution. Note, recompile is not the same thing as output. When using output with recompile with the procs, and we'll do that in a few minutes, when using output with the procs, you need output in two places. Recompile does not need to be in two places, just needs to be in one place or the other. Here's another place things can get interesting. If I execute my proc normally, and I get plan A, then I execute the proc with different parameters with recompile, and I get plan B. When the third person comes along and tries to execute the proc, which plan do you think that person gets? Those of you who answered out loud, "I don't know," are correct. It is completely indeterminate. You don't know if you're going to get the first one or the second one. There have been different times in history where it would be the first one to start. There have been times when it would be the last one to complete. The short answer is you just don't know. As a result, if that is an issue, it is a good idea to alter the proc and create it and recreate it with recompile. Finally, one of the things that you'll find is that once we have that plan up in cache, you go out and you say, oh, I used a tool like Ignite. I found a missing index. I need to apply the index. Oh, wait, nothing's happening. When you create the missing index, one of the things that you're going to want to do is instruct the server to use any indexes in its evaluation of optimal query plans. What the SP recompile does, and again, this is not the same thing as the recompile we've used in the other two statements. What the SP recompile does is it says flag every stored procedure in cache that uses or references this table as unusable. Age them out, get new procs in. So do expect a little bit of a CPU hit if you do an SP recompile on a table that's used a lot. On the other hand, you can expect a lot of things to suddenly get faster. So, creating the proc with recompile gives you a new option every time we run. Using with recompile at execution time gives you a new one. Query plans for subsequent executions, completely indeterminate. Procedure query, so we've already talked about the first few. Add an index does not affect the plans. Now, if we drop an index that it's using, the query plans will be automatically recompiled. It's not going to just automatically switch to a table scan unless, of course, that's the fastest way of resolving things. You do have a couple of ways of flushing existing query plans from cache. One, drop and recreate the stored proc. For a long time, that was the only way. Next, run the dbcc free proc cache. You will need to be a system admin to do that. That empties out everything in procedure cache. Once again, if you do that in a busy production box, expect a CPU hit while suddenly all the procs which were running quickly need to get brought in and recompiled and reoptimized. Finally, cycling the SQL server, shutting it down and restarting it, will get you a new set of plans. A couple of other things to avoid within stored procedures. I'm going to talk about the problem, and I'm going to talk about a couple of the places I see it frequently. Let's take a close look at this proc and see what might happen that would go wrong. Create a proc called getData. We're passing in a flag and a value. If the flag that we pass in is 1, what we're going to do is select star from titles where the price is greater than the value that's passed in. If the flag is not 1, I'm going to select star from sales detail where the quantity is less than value. Let's think about this for a minute. If I'm bringing back titles for a particular price, I might plug in a price like $20. Here's the thing. when I go and optimize this for a price greater than 20 bucks, that next SQL statement is also being optimized, but it's for quantity less than 20, which may or may not make any sense at all. If I'm passing in a flag which is 0 and 5,000, the first time the titles is optimized, it's being optimized for price greater than 5,000, whereas sales detail is being optimized for quantity less than 5,000. Let's talk about some of the things that are wrong here. First, don't make multiple use of the same parameter. They don't cost you anything. There's no longer a practical limit on the number of parameters you can pass in. Here's the place you really get burnt, though, and I see this a lot. People want to, and by people I mean object developers frequently want to have a single stub that is the entry point from a window. So I have a window, a screen, I forget what the GUI folks like to call it these days, a presentation layer on my screen of some sort. I hit enter. What do? Well, if I plug in a value A, I want to do task A. I plug in a value B, I want to do task B. I plug in a value C, I want to do task C. 3 different tasks, one screen. So what am I going to end up doing? I'm going to call the proc, and if A is filled in, I do this. If B is filled in, I do that. If C is filled in, I do the other thing. This pick list type of values tends to create lots of problems for the optimizer that aren't readily obvious at testing time, because frequently at testing time you've got such a small quantity of data in your QA database that it's irrelevant. At runtime, all of a sudden you've got millions of rows of data, and at that point it becomes really relevant. Just something to think about. So, where are we? What we're going to do is make the following suggestion. Instead of performing the SQL within this proc, go ahead and use the stub, but call additional procs to get the individual different types of work done.